Thank you guys for having me here today. Let me tell you about the objectives for our session today. I want to tell you guys a story about Excel, about Power BI, and the evolution of these tools. It's very important, and you will understand why. I want to show you how you can use both Power BI and Excel to analyze data sets that you store within the Power BI, meaning in Azure. I will demonstrate how to do it in Excel and why. Why do we want to do it in Excel and not in Power BI sometimes? So we'll see a little bit the best of two worlds. I will show you guys some ideas and techniques using MDX, multidimensional expressions. Well, and maybe even turn you guys into a super user of not only Excel or Power BI, but the two tools together. There are use cases for the two of them. It's really interesting. I hope you enjoy this. I believe this session can be useful if you are a business user or an analyst, if you want to have some flexibility in the way that you work with your data. There are common use cases for one or the other tool. If you are an IT professional that you want to give some good options for your end users, it's important for you to know the potential of these two tools connected to the same data set, and you can give them different options and different governance for the users. So let me tell you a bit about me, and thank you for the introduction, Ligi. I am team leader at Natix. It's the investment bank of PPCA, one of the largest banks in Europe and in France. I work with multiple teams in BI, in big data, software development. I have two people from India in my team. One who is already working in Portugal, works with the Informatica Power Center in ETL. Another one works with the entire big data stack with Spark, Scala, Hadoop, Hive, with a lot of big data stack. And so every day I have the opportunity to work with amazing people from India, experts in technologies and wonderful human beings. So I'm really happy for the invitation to be with you guys here today and to close the day. I'm also MCSA in BI reporting, and I have a specialization in supply chain from MIT. I worked during my career as a business user. I worked then as a business analyst, giving a high context, of the different needs from different users of data. I worked as a BI solutions architect, as a consultant, and I am invited lecturer also at some events in university. Like Ligi said, I am the co-founder of Power BI Portugal group. We organize meetups every month. Either we have local speakers or we have international guests that come to our meetups regularly. If you are interested to know more, find out the links in the end in the meetup platform that I will share too. And whenever I come to give some lectures about Power BI, Power Platform, and all the data. I love it. I absolutely believe in this technology is a key differentiator for us as the professionals in the IT world. And I think it's the way to go. I strongly believe in it. If I would not believe in it, I would be giving a lecture at the Tableau conference or the ClickView or something like that. But I believe in Power BI, in Excel, in Microsoft Stack. So to go with our session, I want to tell you first why is Excel so popular. This will give us some context about the session that we're going to have. And to give you why Excel is so popular, let's talk about a story about the invention of the spreadsheet. Do you guys know about this story? Maybe not. So please meet the fathers of the spreadsheet, Bob Frankston and Dan Bricklin, two amazing people, really innovators. And I want to show you a little story. The volume of the video is not very loud, so during the video, if you can, please increase a little bit your volume so that you are able to hear it better, and then you can turn it down a little bit again.
One of the first problems that I ran into was, how do you represent values in formulas? Let me show you what I mean. I thought that you would point somewhere, type in some words, then type in somewhere else, put in some numbers and some more numbers, point where you want the answer, and then point to the first, press minus, point to the second, and get the result. The problem was, what should I put in the formula? It had to be something the computer knew what to put in, and if you looked at the formula, you needed to know where on the screen it referred to. So the first thing I thought was the programmer way of doing it. The first time you pointed to somewhere, the computer would ask you to type in a unique name. Became pretty clear pretty fast that that was going to be too tedious. The computer had to automatically make up the name and put it inside. So I thought, why not make it be the order in which you create them? I tried that, value 1, value 2. Pretty quickly I saw that if you had more than a few values, you'd never remember on the screen things were. Then I said, why not, instead of allowing you to put values anywhere, I'll restrict you to a grid. Then when you point it to a cell, the computer could put the row and column in as a name. And if I did it like a map and put ABC across the top and numbers along the side, if you saw B7 in a formula, you'd know exactly where it was on the screen. And if you had to type a formula in yourself, you'd know what to do. Restricting you to a grid helped solve my problem. It also opened up new capabilities, like the ability to have ranges of cells. But it wasn't too restrictive. You could still put any value, any formula in any cell. And that's the way we do it to this day, almost 40 years later.
So you guys see any value in any cell. This is really the power of Excel. It's this granular control that's quite different from some of the BI tools that we have, like Power BI, that you can pinpoint in each cell and you can reference one another. This is the real power of Excel and gives us already some clues about which can be the use cases to analyze Power BI data in Excel. I want to show you guys also how was the look of the first spreadsheet tool, the VisiCalc.
Electroledger. And calculator. The problem I had with term ledger is nobody outside finance would know what a ledger is. But it was a visible calculator, the way I thought of it. So it was obvious that visible calculator, VisiCalc. When Apple was going to go public, they couldn't go public until I found the last bug in the Apple III VisiCalc. So I was trying to find this bug and they were waiting.
This is a very interesting time because Bob was working on the Apple III VisiCalc. And the Apple III was the new Apple, the first business version of the Apple they were going to do. And Apple was holding off going public. The product,
I don't have a direct proof, but
it seemed really weird that as soon as we okayed the shipment, when we finally okayed the shipment, the next day they actually went public.
So fascinating, right? It was so important, this software, for the new Apple release, and when they are going public in the stock market, it's really a fundamental piece in part of the history of Apple Computer and later of Microsoft. So this was such an invention that in Harvard Business School you will see a plate there in one of the rooms saying, in this room in 1978, Dan Bricklin, MBA of 79, conceived the first spreadsheet program, VisiCalc. Really a milestone. 40 years later, this is still the basis for what we do today and so important for many of us today. So going the retrospective about the history, in 2003 we have Excel, the version 2003 of Excel. In 2007 a new feature comes that is quite important also, the ribbon. It gives us more this tool like with some shortcuts and some ease to apply some functions like we know today in many of the normal tools that we use in our day-to-day. Then in 2010 comes Power Pivot, and really where you can model data, you can combine, create relationships between tables and entities inside Excel. This was born already in 2010 inside Excel. In 2013, Power Query is born inside Excel too, that you can do ETL and you can do treatment of data within Excel. And in 2015, July 24, Power BI general availability comes out. And the vision of Power BI on this state is not so different from what we have today.
Introducing Power BI by Microsoft. Power BI is a cloud-based business analytics service, enabling anyone to visualize and analyze data with greater speed, efficiency, and understanding. Get started with Power BI in seconds. Just sign up and you're good to go. Within minutes, you'll see your data in new ways thanks to content packs, pre-built dashboards and reports by popular service providers like Salesforce.com or Google Analytics. And in one dashboard, you'll experience a live 360-degree view of your business. Monitor your data in real time from nearly any device across all major operating systems. Set up mobile alerts to your phone when your data changes, and share your reports and dashboards with ease. Drag and drop features enable you to go deeper with your data and explore it in new ways by asking simple questions. No need to learn a new language with Power BI. Easily clean, shape, and model your data to create impactful, shareable reports. Power BI. Experience your data. Any data, any way, anywhere. Sign up for Power BI today.
So any data, any way, anywhere. I don't know about you guys, but I still have goosebumps when I see this presentation. It's really fantastic. All right, so let's move on. Let me move on to the next part here. So first of all, I want you guys to know is that, well, it's possible to analyze a Power BI dataset within Excel. It's exactly the same thing as connecting to Analysis Services Cube in Excel. You need just to download and install a plugin from the Power BI service, so powerbi.com, and install it in your local machine. So here we go. We click in the big arrow and we download the package. We download this MSI package. We install it, next, finish, and you're ready to go. And then when you go to any dataset, you can go to this demo workspace, you click the ellipsis, and you select Analyze in Excel. It will download an XLS file that will open your model already ready to be analyzed in Excel. It's as simple as this. So we come to the why. Now you know you can do it. Why do you want to do it and analyze Power BI data in Excel? Some of the use cases that, from my experience as architect and as business analyst and as end user, is, for instance, some people prefer to analyze the data in a pivot table format. Maybe some of you already heard the famous expression, wonderful report, but can I export it to Excel? So it's very common, and sometimes it takes some time for the users to get into the mindset of doing their analytics in Power BI, and they feel very much more comfortable using a pivot table. They are used to using it. So sometimes they prefer to do it, or is it because they don't have enough flexibility also in the report to change it, to shape it if you didn't activate the user to create on themselves doing self-service BI. So this is why they want to do analytics with pivot table. Sometimes they just want to automate some of the normal exports to Excel that are being done by the user. So it's another use case. Also, another option is you want to analyze data from multiple Power BI datasets at the same time. So to merge the models together, you can also do this with this feature Analyze in Excel. You can connect a workbook to multiple datasets of Power BI. And the last reason, take advantage of Excel granular referencing. This, like we saw in the Dan Bricklin video explanation in TEDx, you can reference any cell with any formula, and you can reference again and again and do computations on that. If you do it on Power BI with DAX, it will be much more complex to do it. So there are use cases for the two. Other use cases too is, for instance, to feed existing reports. If you have already a huge report configured in Excel, you just want to feed a single cell or two, you can connect and get that data from Power BI Cloud. Other reason can be you want to configure some dimensions. You don't have access to the model and you want to have a custom dimension. You can also do it, or generic data exploration purposes. All these are very valid use cases. So let's see a first demo about this. So what I will do is I will open, here I am in the cloud, and I have a workspace, a demonstration workspace, where I have a couple of reports here. I have a report, I have the data sets also connected to the report. So we can open, if I open one of the reports, you will see it's just a simple report with some sales and with some salespeople and with the geography dimension. So very common report. I will go back to the workspace. If I want to analyze this in Excel, so let's say I want to click here and analyze in Excel, I can do it here, or I can do it in the dataset menu. I also have the option to analyze in Excel. It's exactly the same thing. I already installed the plugin that we've seen. So if you wanted, you could download it from here. You have from the downloads, Analyze in Excel updates, like we've seen. What I will do now is I will click Analyze in Excel in this same report we've seen, and I get an Excel file. I can open it and we'll see what happens. All right. Okay, here it is. My file is already open. And you will see it opens a generic pivot table. When I click on it, I can see that the data is available for me. For instance, if I open total sales, I have the value here, and I'm getting the data from my cube. So if I go to Data menu and I see Queries and Connections, you will see here a connection. And this is an established connection to my data set that is stored in Azure. So I have the connection string here defined, and I'm connecting to Azure. I could rename this connection Worldwide Importers Excel, for instance. I can name it like this. So I give it just a different connection name. What is interesting to notice is that I have here also the Power BI report. Here I have it. And so I have a measure here that I am just multiplying by 2. And you see here 176 in 2 years. I will change my measure in my report. You will see that the cells will become half the value. This is just for you to see that the data changes. I will save it. And now I will publish again my report, my updated version of the report. So when I click publish, my username who is logged in Power BI will have access to all the workspaces he is entitled to, and I will be able to publish my report. So I can select the demonstration workspace. It will tell me it will overwrite an existing report. I replace it and we're good to go. Success. So got it? So you will see here that on the cloud, in the datasets, you see here that the dataset has just been updated this very minute. Now let's go back to our Excel, and if I click a refresh, you will see that the value 396, it gets the new refreshed data from the cloud. So we're good to go. And now I can continue my exploration if I want, for instance, to use, let's say, the state here. And I get a breakdown of sales by each of the states here. So I have this table created. And now I can do the same thing for another data set. For instance, if I want to analyze another, imagine this comes from a different system, and I do exactly the same thing. So I'm going to connect to another data set. Here I go. Doing the Analyze in Excel tool, I have access to my model. I will enable the content. Let's go. And now I also have, I think, my total sales value here. Total sales in my values. And let's see if I have something like a geography, maybe states. I have a state here. And maybe I have a country. I'll pick a country here in the filters. Let me see if I have United States. So now I have my data from this other dataset Global Superstore. If I copy my pivot table here to my other workbook and I place it here, you see now in the same workbook I have connections to 2 different datasets hosted in the Power BI Cloud. So this is the first thing. And now you see I can do comparisons, for instance, in one dataset in the other, and I can compare the data from one and the other. This can be extremely useful in a lot of use cases. So this is first the step on how to connect. And also with these steps, what have we noticed already? Going back to our PowerPoint slide, well, we can see how you can analyze data in a pivot table format. You can automate some of the exports. You can analyze data from multiple Power BI data sets at the same time and take advantage of the Excel granular referencing. Even more, what I'll do also, I have here the workbook already with the 2 data sets here connected. So if we go to data, you'll see I am here exactly what we did right now. I have the worldwide importers and the Superstore data sets connected here. And if I do a double click in this data set, it gets me a table. And this table, if I open the properties of this table, it gives me a DAX query. And what I can do, for instance, is I can instead change this DAX query, evaluate employee, a simple DAX command. And if I change it, let me try again. Can I refresh it? So you see, I got the entire employee table. So I can also do this for the other use case that I was showing, which is, let me go back, automate some of the normal exports, the Excel that are being done by the users. So we covered all these use cases that we can do already very simply with Power BI data and with Excel working together as a whole. Some considerations. Well, having access to this feature, it's great, but if you are on the IT side, it makes you put in perspective a couple of things. You need to have a data set which is clean, organized, with good naming convention and intuitive, because it requires what we call explicit measures. And what I mean by that is if I connect to, let me go back to the model here. So this one, I will show you in a second. Maybe it's better in the Power BI side. Yeah, I have a report here. You'll see this with the sum sign here. This is what we call an implicit measure, because it's just the standard default aggregation that Power BI is assuming. And when you want to create really a measure, an explicit measure, let me see if I have one here. I don't think I actually have any measure here, but it's the one with the calculator sign that we can define, like a count or a sum of a column. It's something like that that we can define. So all the implicit measures will not, if you don't have any explicit measures, then you will not be able to analyze data in Excel. You need at least one explicit measures to do it. The implicit ones that you have in Power BI will not work in Excel. Also, the hidden tables and fields are not available too. And the principle of continuity. Imagine that you have a report that you are not using all the fields that you have in your model. And then when a user connects to the Analyze in Excel, and he can create a custom report with other fields that you don't have in your Power BI report. And then if at any point you want to remove this field, you cannot, because you have users using it. Otherwise, it will have a bad experience for them. So if you allow this feature of allowing the users to use this feature of Analyze in Excel, you have to think about the continuity principle too. So this is exactly what we have seen here. Let me go back. There is a final example I want to show you too. So if I go to Power BI and I open, I think it's a sample report. You have it in the Power BI Custom Stories Gallery. And you see this beautiful demo report that you have a lot of KPIs and everything. But this report, you see 3 tabs, and you don't see actually the model that you have in your report. And so when you actually go to analyze it in Excel, and if I go there and go to the cloud, let me go here. So it's taking just a second. So I can show it here instead of directly in the Excel. So you see in your model, behind the scenes, behind the curtain, there is a whole lot of things. So for instance, you have a table which is called July to December. You have a table feedback, airport codes, custom table. So imagine a user connecting this in Excel and seeing all these tables and all this data. It will be very confusing for him, although the report in Power BI is really neat. So we need to think as BI professionals, if we activate the Analyze in Excel, if our model is really clean and prepared for the continuity principle. So this is why it's important to think about this. So, okay, so we are back here. Other thing also is that pivot tables are really amazing, a great tools for analytics, maybe the worldwide most used tools for analytics in first Excel and pivot tables as the feature in Excel. So they are great, but imagine this case. How can you build something like this with pivot tables? What I mean is that you have in 2 of the years, you want to show the sales, in 3 years, but in the profit and the quantity, you just want to show it in the last year. If you try to do this in Power BI, you drag the dimension of the year plus 3 measures, you will have 9 columns, 3 multiplied by 3. But in a pivot table, it's the same thing. So how can we do this format specifically that we want? So let's go back to our demo. What we can do is we pick one of the pivot tables we have here. I will just copy paste it. I could just create a new one. I'll just copy paste it and I still have the same connection. What I can do is go to the Analyze tab, go to All App Tools here, and click Convert to Formulas. Convert to Report Filter to. Okay. And when I convert this, it creates me an expression. And now this expression here, it converted me the total sales measured as a cube member function. It converted me the dates as a cube member function, the state as a cube member function, and the final value as a cube value function, referencing our connection and the combination of 3 elements, 3 cube members, the state, the measure, and the selection of our calendar. What is interesting about this is that now I can manipulate this data as I please. So if I want to change this cube member to Texas, I can just write here and type it. You will see the value is changed. This is connected to Power BI Online, and it's dynamic, and you can really play with your data like this. So it's really interesting. So now how can we solve the challenge that we've seen in the previous example? So what I want to do is I want to populate this table here. So I'll go back. I have a cube member here of my Texas. I will replace this cell. Instead of Texas hard coded as text, I will click and copy here this expression, this cube member expression. I can do the same thing for other states if I want it. For instance, if I do the same thing here, I will copy actually the text here. And what I will do a dynamic reference of this text and this text and quotes. And now I can drag and drop, and you will see it's just referencing. Sorry about this. Let me delete these objects. Okay, so I have all these cube members here. And now what I will do is exactly the same thing for the year. I have one here for the year. I'll copy it here. I'll copy it for 2014. You'll see in a second what is the effect of this. And I will do the same thing for a measure. I could just go to a pivot table and convert to formulas and copy the formula. I have it here. So remember, I will do the same thing in each of them. Total sales. I have already here the formula for profit and quantity. And now what I can do is write the formula, which is a cube value. I call my connection. And I write a member expression, which will be this one. And I fix the column plus the year. And I fix the row and the expression. Let's try it out. It gets data from my cube, and now I can copy paste this formula and populate without the arrow. Maybe let me just take it out here. And I do copy paste, and everything is dynamic, and very quickly I can populate this table. And now I have all this flexibility. Imagine if I want to do a comparison, how is my sales from one year to the other? I don't have those restrictions with the pivot table. I can do how is this one compared to the previous year -1. And I can do like a percentage, -64%, something like this. So you see, I can do all these analytics. I can go now and do conditional formatting, colors, data bars, something like this. So a lot of things I can do. So you see, I have complete control over my data at a granular level. So going back to our PowerPoint, now we are able to fix and solve this problem. It's important for you to know about this to understand the language of the cubes, which is you have three functions: cube value, cube member, and cube set. These are the three basic ones. So to call this expression, to call data from a cube, you start typing a cube value, you reference your connection, and then you can put as many members as you want, 1, 2, 3, or as many members plus cube sets as you want. Some rules: you can cross any number of members and sets. You can only use in one measure, for instance, total sales or profit, but not the two, of course, it will throw an error. And the maximum one element at each dimension. For instance, only the category or subcategory, but not the two of them. So you need to pick one by each of the groups. You can also manipulate MDX formulas, like I just showed you, to reference dynamically the Texas, Pennsylvania, etc. I can reference Texas and put that in the middle of a formula in these expressions. And we see that with this convert to formulas, we give independence for our cubes. We can just create in each of Excel cells, we can call any data that we want from our cube, giving a lot of power to very granular reports, like for instance we have in SSRS, but in a very simple way with the Power BI and Excel together. So other thing we can do is using these cubesats. And I will give you a quick example on that. On the cubesats, what we can do is, I want to have the total sales by a group of salespeople. For instance, all these ones. I have already here a cube member, 1, 2, 3. What I want to do is create a cubeset that is called Mr. Johnson. So what I will do here will be a cubeset. I'll call my connection, worldwide importers, and the expression will be just this, the merge of these people, and the caption will be Mr. John. This is it. It's getting data, and you will see now that if I can also start typing a formula from the beginning. I can connect to my cube. I will show you. I can do value. I can call my connection worldwide importers, and now I can call one of the members. For instance, I want from my sales, not my sales, I think it's from my measures. Yeah, I want from my measures, I want to have my total sales. Let's try it out. So this is my value of the total sales. Now I want another element, which is going to be Mr. Johnson, this cubeset. And so you will see this is actually the total sales of, I also need to put here the year. I'm missing here the year. So let me reference also the year. Fix this one, and here we go. I don't have sales in 2014. Let me see if I have, yeah. In 2015 and 2016, I have some sales. If I change this cubeset and say, oh, this cubeset is just these three people, you will see that the values will change. Now it's only the sales of these three people together. So this is really powerful, and you can do custom groups as you please. I can do exactly the same thing, you see. I can do the same thing for Mr. Smith here, or I can just reference an existing cubeset. I'm referencing this one that by itself it's a cubeset, and when I copy my formula, it will work. I can do the others too. How can I do that? Well, I'm basically going not to reference any salespeople. So I'm getting the total out of all salespeople, and then I just do Excel, this minus the sum of the other two. So plain Excel, and I can do this in a very easy way. So this is really powerful. I didn't reference, yeah, the measure I hard-coded here, but I can reference dynamically here the total sales. This is why it didn't work. Otherwise, it will always be total sales. So if I reference here dynamically, then it will work. You see, this is the way that we can do it. So another example, let's go back to our presentation of cubesats. You can also adjust this for time. This is not so many use cases, but just for you guys to know that is also possible to do it. And you can convert date formats with this formula text, and you can change it to a format that you can manipulate as text. So we come to we've seen already these three cases. Now, for instance, if you want to feed existing reports, configure some dimensions that are not available as you want. We saw this with the salespeople. And other data exploration purposes, we also seen it. Let me show you another use case, which it can be interesting to know. To feed existing reports, let me show you this one here. What I mean by that is, imagine you had a report here from marketing. They have other KPIs from Google Analytics or something like that. And now you are changing your sales data from another reports that you had in Excel, a World of Excel, etc. And now you have your sales cube. And you want to connect the formula that you have here in this cell to that data that is in the Power BI, but you need the rest of the report connected to all your marketing data and etc. that you in NPS and stuff like that you have in other data sources. So how you can do that? Because you cannot do an entire Power BI report with all that. You want to keep the data that you have from the other source. Well, it's very easy. You keep your report as it is, and you get the data as we explained: cube value connection worldwide importance, and then you recall the expression of the total sales. Total sales. Right? You want to know. Okay, it's divided. It's like this. If I do exactly the same thing here, but I change the formula total sales previous year, you will see now my report is connected to the cube with exactly the same format that I had before. This data comes from the Power BI data, and the other thing is completely linked to whatever it was connected before. So this also is working just fine. So maybe this is not so simple for some of the users. How could we make it more simple? I will tell you the thing I did for a couple of them to make it really simple to use and just get any data they want in Excel. I create what is a base, and I use it with a combination of named ranges. So this is the solution I propose. Let's see a demo about it. So what we can do is I create a base, and I copy-paste the cube members from the dimensions that I use more regularly here, like the one we've seen from Texas, Pennsylvania, etc. And I give it a name. I can go to this cell here, and I can call this cell Texas. What this means is when I click equal to Texas, it references this cell here, which is by itself a cube member. Imagine I put some data here, and now I can reference, and I call this my sum range. And call this. So when I click equals to my sum range, it will reference, or the sum of my sum range will give me the total, referencing the cells that I just give it a name. So I can continue to do this. For instance, I will call this expression total sales as sales. I will call 2016 as, I think it's, what is the name that I want to give it? Year 2016. And I can give names for other periods. For instance, last 1 week real, last 1 week history. I can give it names like that. I can call this Easter history, Easter real. So after doing this, what can I do now? Let's try it out. I want to have the sales of 2015. So cube value, worldwide importers, sales, year 2015. And magically, with this combination, it gets me the sale just of 2015. If I wanted 2016, I can also get it. So it works. Profit of 2015 in Texas. Cube value. Action. And then sales. Year 2015. Texas. So all this combination. And I click enter. And I get the data from my cube just as I'm typing whatever I want with this combination. So it's really powerful and works just fine for the users. So considerations about this: any cell can be assigned a named range. There are some rules about it. It can only contain letters, numbers, periods, question marks, and the scores. Cannot contain space or start by numbers. That's why I give the year 2015 instead of 2016 to name it year 2016. So you can see here a real use case for some people that needed information about sales in a store. You could type here the number of the store, and it gets data from your cube directly in the sales or anything else you want. It gets your sales here directly getting from the cube in an Excel sheet without the user having to do anything like that. So just a simple example of getting data in seconds. How does this connect with Power BI and Excel architecture? Well, you see here that from the data that you have hosted in your cube, as you know already before that you could analyze it with in the browser with Power BI, but you can also now, what I'm showing you today is you can also analyze it in Excel too. And you can also create some things in Excel and publish some workbooks also to Power BI, although I don't think it's the best practice and I usually don't use it a lot. So use this reference diagram by Dustin Ryan. I love this one. It's really cool as a reference for the architecture. Some takeaway notes. Well, analyzing Excel, I think it can be handy according to the maturity of your corporate analytics, self-service BI, and also to have a KPI action-driven ability. I think it depends really on the maturity level that you are. Can be more useful, can be less useful. Even huge organizations like Maersk only recently moved to CSV, to Excel, and to data silos to a tool like Power BI. It's important also to keep your models clean and concise, to think like we've shown in the examples about the naming convention, what it is to come. And if you can't deliver everything you want to your stakeholders, isn't it nice that you have some options to do? Maybe they already have options to work with the data that they want in the format they want with this option of the Excel, and you don't need to create a custom report for them or really mess up with your model. So it's great to have options for your customers to be satisfied. And I leave you here also the contacts. Please, my email if you want to get in touch, my LinkedIn too, and also my blog leadingwithdata.net. Please get in touch with me. I'm really pleased to be here with all of you together in India and to close this session. Thanks again for the invite.